Now the next property is reaction with halogens, that is probably with fluorine, chlorine, bromine and iodine. So what we see is that metal reacts with halogen forming the respective metal halides. As we know that alkali metal has positive valency and halogens is a group which has a negative valency. So it will form MX, particularly with M with positive ion and X with negative ion, and particularly the bond is ionic bond. But as far as the reactivity is concerned, so as we move from lithium to this thing, lithium, sodium, potassium, rubidium, cesium. So as we move down, we know that size is particularly increasing. And when there is increase in size, that means nuclear charge is somewhat decreasing and even the ionization energy is decreasing. So that means it is very easy to remove an electron from the metal which is present below as compared to the metal which is present in the at the first series. So that means lithium form an halide obviously, and their halides are actually, you'll see that it is covalent in nature. We'll discuss that later. But as we talk about this thing, the reactivity goes on increasing down the group, and the cesium somehow react more readily with the halogen forming halide as compared to the lithium. The reason behind is the size and the ionization energy. Now the next property is solution in liquid ammonia, which is one of the very important property. What we see that metal actually dissolve in liquid solutions of ammonia, and what they form ammoniated cation and ammoniated electron. Again, metal dissolve in liquid ammonia forming the ammoniated cation. This is the ammoniated cation, as you can see the positive ion, and this is the ammoniated electron, as you can see the electron here. So you know that due to these two things, the ammoniated cation and ammoniated electron, it is actually you can say a good conductor of electricity. And due to this electron, it is actually colored because there is an unpaired electron, so we can just excite it, and we know that when we supply it with energy, it gets excited to high energy level. High energy level remain is unstable, so it jumps back to its ground state, and in doing so it liberates the energy absorbed. So what actually this electron do, it absorbs the red light of the visible region and get excited to the high energy state, and then when it returns back, the transmitted light is actually blue in color. So that is the reason that when metal is dissolved in liquid ammonia, particularly the color or the color of the solution we obtain is blue. And on diluting, this blue becomes more dark blue, but when we increase the concentration of the solution, what we see that the color changes from blue to copper bronze. Now what is the reason that it changes from blue to copper bronze? The reason is that when we increase the concentration, the metal ion actually form the clusters. So that means metal ions are getting paired up, you can say. So as they form the clusters, so that leads to the formation change in the color, that is they form copper bronze color. Now as I told you that as far as the conductivity is concerned, cation and electron both are responsible, but when we increase the concentration, what happens actually that when we increase the concentration, the conductivity actually decrease because cation gets paired up, and we know that for a substance to be good conductor, there should be a unpaired electron, then only it can act as a, it should have ions actually, then only it can be good conductor. But here what is happening, when we are increasing the concentration, it is actually the cations are getting paired up, or due to the reason there is lack of ions, and as the ions, number of ions decrease, so that means the conductivity also decrease. So it is one of the important property, and you should know that ammoniated cation and electron is formed when metal is dissolved in ammonia, particularly like both are responsible for the blue color. And why they form the copper bronze, because on increasing the concentration they get form the clusters, and the clusters actually appear to be copper of bronze color type. And as far as the conductivity is concerned, when we will increase the concentration, obviously they will accommodate more electrons, they will be expanded metals, so and the conductivity will particularly decrease. So this is how you are going to answer the solution of alkali metals in liquid ammonia, right.